Okay, so I'm going to be talking about global modelling, but in the context of forecasting from NWP, weather forecasting timescale to seasonal timescales, and for that I'm looking at what we're doing at the Bureau. But first of all, just having a look at some of the broad trends in global modelling into the future. Clearly in the international community, there's a move to kilometre scale global models. We're also on an ongoing pathway to systems that have increasing complexity, are more integrated, and so that they produce more consistent outputs from different domains. And Chris is going to, for example, talk a little bit about that in terms of hydrology, bringing hydrology into modelling. I think we're going to have a much more seamless approach to our forecasts across the timescales going into the future, and part of that is ensembles are key for that. And then it's obviously become very clear that going into the future, our models and our systems are going to be increasingly interwoven with machine learning. But to step back now to where we're at the Bureau for our global modelling. So we have three global forecast systems. For our weather forecasts, we use ACCESS-G or G for ensemble. For our ocean forecasts, we use ocean maps. And for our seasonal forecast, we use ACCESS-S. But as you can see, ocean maps and ACCESS-S use different ocean models. And our NWP and our seasonal forecasts use slightly different versions of the atmospheric model. And we're also quite far behind the Met Office in those operational configurations. So where we want to try and head is work on our development and evaluation much more closely with the Met Office. Be more up to date and focus on consistent configurations. So we're heading towards our first sort of what we're calling seamless configuration, and that's going to be based on a global coupled model version 5 from the Met Office, which includes GAL9, the atmosphere land component, and GOSI9, the ocean and sea ice component. And so for our weather forecast upgrade in around 24-25, it's going to be based on a coupled model, and it will be based on that coupled model. And we will use that same scientific configuration for our seasonal forecasts. And at the same time, we're looking to build a prototype ocean forecast that will use the ocean version of that. So that's where we're heading in terms of that sort of consistency. So basically, our strategy is that in order for us to be able to be competitive and keep up with global modelling, we really have to be closely aligned with the Met Office and leverage off their capabilities. But to do that, we want to play a more active role than we have in the past in the development and the evaluation process. And we want to have that process more focused on Australia and what matters to us. So this just shows the governance sort of structure associated with Met Office and partners for GC, so that's Global Coupled Modelling, and GMED, which is the Global Model Evaluation and Development. And we actually have Australian representation in that structure. So Oscar Elves is a partner representative on board. Oscar, myself, Harun and Martin are on the partner coordination group. And then the Met Office also run what are called PEGs, process evaluation groups. And one of the PEGs that we co-lead and is important to us is called the Indo-Pacific Priority Evaluation Group. And so what that really does is it's a targeted look at trying to tackle some really persistent biases that we know exist. And these biases persist not only in forecasts, but they persist in long coupled simulations, in AMIP simulations. And so the idea is, how can we actually tackle that? And I think that that's kind of one area where we can engage more in terms of the national community in looking at some of these areas and persistent biases. Okay, I wanted to give you some indication of model releases, and don't worry too much about the table. So it basically shows releases of the models from the Met Office. And if I want to look first of all at our operational seasonal prediction, at the Bureau we're using what's called GC2, the Met Office are using GC3. And if I look at our operational global weather forecasting, you can see that we're using a version that was frozen in 2013, and the Met Office are using GC4. So the Met Office are actually using a coupled model for their weather forecasts. So we want to try and close that gap. So to do that, we need to be involved in the Met Office's cycle of development. And so basically, this is kind of the pipeline of development. There's the model development component, and that is all about sort of building new components of the model, like maybe your convection scheme. And it can be on a timescale of anything from 1 year to 10 years. And so this is not a linear process. And then there's the release and assessment cycle. So in the release cycle, it's all about building the new model configuration. So you're putting together your new microphysics scheme or your convection scheme or whatever it is, putting them together, seeing how they work together, tuning the model, and at the end of that stage, a configuration is frozen. And then there's a whole lot of assessments that are done, and then after that, there's the operational side of things. But at each stage, there's a whole range of different evaluations that are done. So it's tested in terms of free coupled runs, AMIP simulations, forecast mode. And so these changes in these configurations are tested in a wide variety of different circumstances. So at the moment, where are we sitting in all of this? So we have a small component in the model development part. We are not actually involved in developing a new convection scheme for components, but we are involved in testing and evaluating it. We do have some work looking at how to parameterize sea breezes in models, which will be linked to the convection, and some work looking at how we can maybe represent interactive vegetation in the models using a machine learning approach. But our main focus is in that little area there, looking at evaluating and testing a new configuration. And that evaluation and testing then would eventually feed back into the development process. I'm not going to talk about data assimilation today. So just to give you some idea, so this is actually the first time that we've been involved early on in this development process of the latest system, the GC5 system. And I'm just going to give you an example of two sorts of things that we looked at. And this one is I like it because it's kind of a user-focused metric. It's looking at the northern rainfall onset over Australia. And at the Bureau, one of the forecasts that we issue is what is the chance that you're going to have an earlier or later onset of the wet season. And so having this kind of metric is also really useful because it can be used to show to users and funders the value and of doing sort of model development work and evaluation. Anyway, so this metric, this diagnostic was developed in conjunction with users, and it represents when there's a 50 millimeter of rain accumulation after the 1st of September. And essentially that's when you start seeing pasture growth after the dry season. And you see earlier start dates in Western and Northern Eastern and Northern Australia around November, and later start dates in the Northwest, maybe in February. But the key point is that onset date is strongly modulated by El Nino. So the blue in the top diagrams there show earlier onsets. So you can see in La Nina years, you get significantly earlier onsets of this wet season. So we wanted to see if our models could actually capture that. So at the bottom, we were looking at a GC4 prior version and the GC5, and we were looking at the onset dates in La Nina situations compared to El Nino situations. And you can see that the GC5 model does a much better job at capturing the earlier onsets that occur in La Ninas, whereas the GC4 model didn't get it at all. And the other thing that we might look at, for example, is the relationship between El Nino and Australian rainfall, and that's just a regression. So in that way, we're sort of focusing some of the evaluation on things that matter to us. So to do all of this, really infrastructure is key. We need to be able to get across the latest model versions from the Met Office so we can run our own experiments, test it, feed back into the development cycle. And it's not only about the model. So we talk a lot about models, but for us, there's the suite as well, and that can be really complex in itself. So you have a model GC5, you can run that model in free running coupled simulations, or you can run it in forecast mode, and they come with very different suites. And those suites need to be portable if we can use them. And so that's also true if we're going to be able to collaborate as a community in Australia. So one area where I think is an opportunity to collaborate more is in this coupled NWP research suite, which we've ported across in the last 2 years. And this suite has the ability to do atmosphere only or coupled forecasts. You can run hindcast sets. So for example, at the moment our test bed is over January 20 to June 2022. You can also, with the suite, run ensembles, and you can also do focused case studies. And we use it to look at a whole lot of different things, like different configurations, impact of convection scheme, look at high impact weather forecast cases, etc. So one example I'm going to show you now is our evaluation of this new co-morph convection scheme. And we've looked at this in an AMIP run, and we've also looked at it in this forecast configuration. So it's quite interesting being able to see, do the insights hold across different configurations. And so, for example, here, this shows the bias in the left of the GA8 model for rainfall. And one of the persistent biases is a dry bias over the maritime continent region. And on the right, you can see when we use COMORPH compared to the GA8 model, COMORPH significantly increases the rainfall over the maritime continent. Another example is we've looked at tropical cyclone cases, and this just shows Saroja. On the left is looking at forecasts of the tropical cyclone intensity, and in the black it shows the deepening of the observed tropical cyclone. The blue is GA8, and you can see it doesn't get the deepening at all, whereas the red with COMORPH gets it much better. And the red track with COMORPH, it gets that southeastern transition, extratropical transition. And then the other thing we can look at, for example, is, things like the MJO. How well can it actually forecast the MJO? And we've used that test bed again to do that and looked at, what is the impact on forecast skill for the MJO? The other area where I think we can actually engage more in terms of our national community is with ACCESS-NRI. So that's our seasonal prediction model. But here I'm not talking about being used for the explicit role of forecasting, but actually using it as a tool to understand climate variability and change. So, for example, we might want to know a bit more about why we got the triple La Nina. So you could do an experiment where you initialize the forecast model with the realistic land and ocean initial conditions, but you use random atmospheric initial conditions. And from that, you can see what kind of influence the atmosphere had on the forecast. And both Lynn and Umpar have posters of other examples where ACCESS-NRI has actually been used as this kind of attribution tool. So finally, I think we have some both challenges and opportunities going forwards. We need to be able to work with the Met Office, but work out what is our priority, what are our priority areas, and where can we actually most add value. It's a challenge to work seamlessly across the forecast timescales, and it's also going to be a challenge, and is a challenge, keeping up with the Met Office. But the one I want to focus on is, can we actually improve our collaboration and our capability in global forecasting by drawing more effectively on the partnerships that we have in Australia. And I think that perhaps the ACCESS-NRI may have a role to play in that. And I also see the new ARC Centre of Excellence as potentially helping with that. So the key points are, I think there are areas where we can engage more in terms of the forecasting and prediction side of things and how it relates to research. And I've sort of given an example of 3 in terms of that sort of Indo-Pacific type tracking of persistent biases, potentially using something like a research suite for weather forecasting and a seasonal suite. And then, can ACCESS-NRI actually help facilitate improved collaboration in this space? Thanks.